mission, the Apollo mission, but it's not true. I mean, the humankind has been dreaming, looking to the space since the very origin of the life. And we will go through this concept. First of all, I will share with you a video that is presenting Italia Space Agency. I hope that the audio will work. Even if the audio is just sound on the background, then you don't need that. It's a very short video that is showing you some of the major activity Italy is performing on space. Okay, then let's even present myself with two very important for me pictures. The one on the left is myself with my father observing with a telescope. And this is the beginning of this dream I have with me. And this has been an inspiration for me to do our job in space sector. The last one on the right is recent with my grandson. I have an astronomical observatory, and I try to pass to the new generation this dream, this passion of space exploration. In the past, I was engaged in many missions. This one is one of the best in terms of remembers. Is a double space shuttle mission embarking a radar to observe Earth. This was in 1994. I was engaged in the control center in Houston. This, of course, for me was really a dream since I was a child when Apollo mission has been controlled by Johnson Space Center. This is the last one, last year, is a joint NASA-ASI mission. We were performing with the lander, robotic lander, an important experiment on the moon. We tested an Italian satellite navigation receiver. We check that it works even 4,000 kilometers distance to catch signals from GPS and Galileo and to get the position on the moon. This, of course, very important for the future exploration mission on the moon. That is to welcome, I don't know if our friends from Afghanistan are connected. The idea was to show Afghanistan, Scotland, the Wallace High School, then jumping down to Turin, to our friends in Ciampini-Boccardo, and then finally to Italian Space Agency in Rome. This just to see that the world is very close, has a very small environment, and this is the reason for which we look outside. And then my presentation is mainly organized in 4 steps. First of all, some consideration on our planet, and then our point of vision is, in my opinion, really an incitement to space exploration as such. And this is the reason for which, for 1,000 years, observation hypothesis has been made, looking to the stars, to the sky, making measurements and developing technology. Then, of course, as soon as we were in position, we left our planet to go in space with robotic missions, satellite, but even with astronauts. And finally, of course, a short description of the future of space exploration, and something that you as a student are, if you like, in charge to develop in your future job. Then our planet. I was thinking that we are very, if you like, lucky to live in such a planet because in my opinion, there are 4 major special conditions that are, if you like, in some way supported our curiosity in performing space exploration. There is a perfect atmosphere. There is an orbit of our planet around the sun that is ideal for a number of reasons. We have a special natural satellite, the moon. Is not a given to have such a satellite. And then we have a special family that is a solar system. These are all characteristics that are, if you like, helping fostering our, if you like, curiosity. Then let's concentrate on the atmosphere. This is the, if you like, the major concept is, of course, to protect our life. We know that if we go outside our atmosphere, we are died for the radiation, solar radiation, and we cannot survive. Then, for sure, the atmosphere is a shield to protect ourselves. It's also very dynamic. We know weather is changing, there is wind, rain, and this also supporting life. And of course, an important characteristic is tiny and sometimes very transparent. This allows to see the stars, moon, and the planets, even with naked eye. And this has been, since the very beginning of humankind, a way to, if you like, introduce, if you like, the willingness to look outside our planet. There is also an ideal orbit, is named the life zone, is ideal in terms of temperature range, is a precondition that is fundamental to develop life. The duration of the year is not given. I mean, we can enjoy in our life tens and tens of years. We can, if you like, experience several orbits or even of giant planets to observe the universe in some decade, personal level. And then there are seasons that, thanks to the axis of the rotation of Earth, allows us to enjoy even different seasons. Then there is also this important sister that is the moon, that is a very big satellite. If we consider the size of our planet compared with the size of the moon, that is more or less 1/4 in terms of diameter, is quite, if you like, fortunate combination, because if you consider the size allowing to see the moon with naked eye, even to take some details on the surface of the moon. In addition, the size of the moon compared with the distance of the sun, that is very big, of course, if compared, makes possible the eclipse. This is a strange combination of relative size and relative distance. This is a unique event on our planet, to see the sun that is obscured by the dish of the moon, and the opposite, the moon that becomes red because the earth is in the middle. Then this, of course, is showing a lot of details. In the past, even without a telescope, people are observing details on the moon. Another interesting characteristic is the effect of the tides that are on the, if you like, economic development of entire generation of human important, in particular, if you remember, Egypt, the Nile River is making floods during a specific times and period of the year, and this was an event strictly related to the phase of the moon. In general, the moon is a relatively close extraterrestrial body that is allowing, if you like, in-person exploration. This is a very fortunate case because in few days you can reach the moon with a spaceship with on board astronauts. If you have to go to the closer planet, that is Venus, you need months. Mars, 6 months, and then, of course, it's a little bit different. Then a very special solar system family is another consideration we can do. We have solid planets at the very center of the solar system and giant gas planets out in the external region. The ring of Saturn that are visible even with a very basic binocular or a small telescope are something that is really fantastic to be seen, and is linked to a very basic physical effect of debris around the Saturn planet. Then there is a lot of satellites and small objects in addition to the 8 planets. And then in general, the size of the solar system is allowing, and this is not, if you like, a trivial case, robotic mission. Today, Voyager, that is the spaceship developed by humankind that is in the far distance and never reached before, is so far in each year is increasing the distance that the radio communication takes 24 hours to reach Earth. Then you can imagine how much is distance this piece of technology developed by human. And then, of course, there is a challenging of human exploration because the size is not so big. We can even dream to go on Mars with astronauts, and even more on asteroids, and developing human exploration that is to be developed in the future. Then let's try to image a wrong planet. Let's imagine to have our life developed on a wrong planet. That, of course, means to have a wrong atmosphere. maybe abnormal orbits. There are solar systems that are composed by multiple stars. Then the orbits are very complex in terms of periodicity, and it's even difficult to predict position of the stars on the sky. Maybe no natural satellites at all. And this, of course, makes us, of course, on an unfortunate planet, blind to see the universe. Imagine a wrong atmosphere. If you compare with our sister planet Venus, Venus is completely covered by clouds. Then if you see the sky from the surface of the planet, you see just clouds. And then you can imagine what it means to live on a planet where you cannot enjoy the show of the stars, planets, comets, whatever is the object. Then it's really a matter of developing the curiosity of our scientists without having the show available. Indeed, living on Venus, the only way to make space observation is to use a radio telescope. Then imagine to have condition which you don't have a moon around our planet. Means that you cannot observe a very big celestial body in the night. Then you need a telescope. Only if you like something that is quite recent in the history. We, of course, cannot have lunar tides effect on agriculture, on life. There are theories that are saying that tides are fundamental for the development of the life on our planet. You can imagine no solar and lunar eclipses, of course. And then, of course, there are no useful example when observing the other planets. And then having our natural satellites, we can make a comparison, for example, observing Jupiter, having multiple satellites around it, and then we can make a parallel. And then, of course, the absence of the moon means that a few days trip for astronauts is not possible. And then imagine even an unfortunate solar system family. Imagine to live on a unique planet on the solar system, just to have the only one rotating around the stars, without the show of the Saturn rings, or even imagine to live on a very big solar system that's so big that to go from a planet to another, you need thousands of years. That is something that is not practical. Or maybe imagine to rotate around a double multiple stars. Then the complex asynchronous sequence of night, days, computation of the orbits of the stars on the sky is so complex that becomes impossible to make development of theory like Newton. Then now let's go to the second part of my presentation, that is the exploration of the space from our planet. And this is a short 6 steps story of the humankind observation of the sky. At the time of Babylonia, they already noted the cyclic frequency of the Saros cycle, that is the 18 years, 11 days, in which you have exactly the same position of the moon on the sky together with the sun. This has been, if you like, predicted by Babylonia, and then you can imagine how much these characteristics of periodicity is important. In Egypt, in the past, the calendar was based on big stars visibility, because by means of this period they can develop a calendar, that is this one you can see. Is a calendar based on the visibility of big stars, and if you like, is a way to know in advance floods that are fundamental for agriculture at that time. Then, of course, is well known the development of a telescope makes a giant leap, because observing the sky with a telescope, you can detect details that otherwise with the naked eye you cannot see. There is, of course, a lot to be said on the observation of the sky, because at the very beginning, the astronomers were not able to distinguish a star from a galaxy, from a nebula. Then a number of different hypotheses has been developed to distinguish between stars of our Milky Way and stars that are outside, combining other galaxy. Another interesting phenomena is the Cepheidis variable stars, that are a very fortunate opportunity, because by means of this strange behavior of these periodic stars, are stars that are changing their intensity of light with a period that it depends but the size. Then in few ways, this is a way to compute Cepheidis stars, variable stars distance according to the periodicity. And this trick has been very useful to compute distance of the stars on the sky. Another very big giant leap has been the introduction of spectrograph. That is a way to decompose the light coming from stars, planets, into different combination of the lightweight of the spectrum. And this, of course, even introduced the concept of composition, because on the spectrum you can see the black lines that are absorption of chemical composition. Then this, if you like, instrument allow you not only to see stars, but even to know their composition. And then, of course, the last step has been the introduction of telescope in orbit on space. This, of course, is removing the limitation of the atmosphere and making another giant leap. Then the story to leave our planet to explore the space outside our planet start, of course, the first way to live, if you like, the surface with balloons, airplanes, but everything is passing through the theory of the Newton law, the concept of trajectory, that is, in fact, in the ballistic field, in the military field developed with mathematical models. If you develop the trajectory increasing the velocity, you obtain an orbit around the Earth. Then the concept of orbit is directly coming from the ballistic development. In 1957, we had the first artificial satellite, Sputnik. In the first man on space, Yuri Gagarin, in 1961. And then we observed the start of the space adventure with robotic exploration of the close object like Moon, Mars, Venus, and then, of course, the well famous landing on the Moon for the Apollo mission. But even very complex robotic exploration like landing on Venus, on Mars, the first interplanetary spacecraft, the Voyager, I was referring before, has been launched in 1977, is still working. It's a miracle of technology. You have to think that when has been designed, the technology on Earth was completely different. but the engineers work on Voyager are so clever that they made the software upload several times on board of the spacecraft to allow to take commands and telemetry from the Voyager even in very far position. Then very interesting, recently in 1924, we had the first drone flying on the atmosphere of another planet on Mars. This was really interesting to see future development. Today we have more than 300 spacecraft sent on space, 25 of which are still active. And today we have more than 11,000 active satellites orbiting Earth. And this, of course, is impressive, even in some way creating a lot of problem to astronomers, because it's a sort of pollution of the night sky to observe the universe. This is something that I suggest you to download from the GPL NASA site. It's very nice scheme. Is an iconographic panorama of all the solar system missions with the name of the mission of spacecraft and the object observed. You can see that in addition to planets, there are asteroids, comets, and it's quite nice iconographic panorama to maybe to be printed and attached to the wall of your school. But how you navigate on space, because it's not simple. I mean, we are familiar to navigate on our planet using navigator on our smartphone using GNSS, but of course, as soon as you leave our planet, you go far in distance, you cannot use a traditional navigator. Then in general, there is the concept of absolute space positioning. This is made through the star trackers, that are instruments that are in some way making triangulation with the known stars, like the ancient sea navigators. In the satellite navigation, if you are inside the space volume that around the Earth, otherwise you cannot use it. And then there is also the concept of relative space positioning. Then you can imagine when you have a docking between two spaceships, you need relative position very accurate. There is a laser ranging, radar, and even the process of telecommunication data. Since data on telecommunication channels are traveling at the speed of light, this can be used to measure the distance. And then there is also the need to measure the attitude orientation through the gyroscope, magnetic sensors. If there is a field present on the moon, for example, magnetic field is sometimes absent, you cannot use a magnetic sensor. And recently, with the artificial intelligence, has been developed a way to use camera that are used to process in real-time image of the surface of the body you are exploring, double checking with the known predefined maps. You can define your position thanks to these techniques. And then the last one, that is one of the most important, is time synchronization. When you fly on space, very far from Earth, the delay of communication introduces ambiguity on the synchronization of events, especially if you have maybe astronauts working on the moon, satellite orbiting the moon, you need to synchronize very accurate each event. This is the reason for which we made last year this experiment on the moon. I was personally engaged on this experiment that is a world record. We made this experiment measuring the GPS and Galileo signals on the moon, something that has been never made in the past, and this, of course, opened the door to future development of exploration on the moon, knowing the position on surface. This is a list of record. I already made a mention to this helicopter that is flying on another planet. Another very interesting mission is in the field of protecting our planet is this DART mission, in which has been even engaged a very small CubeSat named Delizia Cube from Italian Space Agency that was in position to take image during the collision of this small double asteroid. And the idea was to test how much we can deviate orbit in case there is a risk of collision with Earth. This is a very unique image of Venus, of Titan surface, that is the biggest satellite of Saturn. This is another mission which ASI has been engaged. You can see the surface of another body that is a very big satellite that is almost the size of Mars, with an atmosphere, and then is a candidate to search for life. This is an impressive picture taken very close to the surface of an asteroid. Is a Rosetta mission. This is the last image taken by the spacecraft before touching the body to take some picture of the comet. This is another interesting mission. Is a Japanese mission, Hayabusa 1, that was able to get samples from the asteroid. You can see on the bottom right the shadow of the spaceship just before touching the surface, and even bringing back to Earth the samples collected. And then the first time we get on our laboratory samples of an asteroid to search for decomposition, even to explore how much the life has been developing on our solar system and not only on our planet. This is another mission that is currently running. Is a Chinese mission that is aimed to make two different rendezvous, one to an asteroid and then to a comet. And this is another example of recent mission. Is CHEOPS, is an European Space Agency mission, is a space telescope that is fully dedicated to the search of exoplanets, that are planets that are orbiting around stars, then very far, in which you need techniques to detect the planets, because the only way to observe these planets is to observe a reduction of the light of the star when the planet is passing between us and the stars that we observe. Then a sort of mini eclipse that can be detected just with a very sophisticated telescope. This is another mission that is under development. Is named Plato. Again, in this case, we have 34 different telescopes that together will allow us to go very far in discovering exoplanets. Then now we can ask to ourselves about the future, the next step in space exploration. And then, of course, the first development that has been engaged is to put on space a very big telescope. The last one is James Webb. You can see in this small picture the comparison of the Hubble mirror and the James Webb mirror with hexagons. It's very big, and this is also if you like, using the absence of atmosphere to have capacity to reach resolution that cannot be reached with a traditional astronomical observatory on Earth. Then, of course, there is, in this picture, you can see is a way in which an hypothetical space telescope observing our solar system can detect Earth, Venus, and Jupiter, imagine to be on the opposite side on another star observing our solar system. Then the next step is the development of artificial intelligence, especially to process this huge amount of data that are collected by all these missions we have seen before, that not only telescope, but also spacecraft on the solar system. Then data analysis and detection of specific sign of life are fundamental in looking for exoplanet. And then, as you know, the development of space station on Earth, on Moon, on Mars, and the exploration of our natural satellite with a permanent presence of the space camp is, of course, one of the next steps we have in front of us. And this, of course, is based on the capacity to have a combination of robotic asset, astronauts, maybe in situ resources, then maybe to use the on the moon the regolite, that is the surface principal components of the moon, if you're to build homes, protection of our habitat modules with this 3D printing technology. And then, of course, in general, the concept of sustainable space economy, that is, if you like, linked to the opening of the private actors working together with the public actors. Then now space is really a combination of public and private commercial actors. Then in general, one of the most if you like, interesting future way to explore the universe is what is named the intelligent autonomous space entity. The acronym is EASE. That is quite interesting because the idea is to develop technology that is able to fly on the space without any support from Earth. Then are entities that are able to take decision to collect data without having predefined plans before the mission itself. That this, of course, implies a number of question marks because you can imagine the concept of total autonomy introduce some liability framework. I mean, you cannot imagine to have such autonomous missions without having ruled the way in which this robot can act on the space. Then in few cases, let's say, we can say that the future is not engaged only engineers, chemical, physics, astronomer, but we need even lawyers, legal people to regulate at the international level the way to develop such very sophisticated technology. In the past days, I sent you some material to build paper models. This is just an example. You can have a very nice reference to website content in which you can download paper models. In particular, I sent you the Ligure mission space model. These are some references you can use from your side, even offline, to get educational material for teachers and for students. And these are the reference of ASI if you want to keep in touch with us with a number of social network, YouTube, X, all the different platforms. Then as a second step, I will show you briefly even another content that is again a panorama of the application smartphone that are, if you like, helping you to transform your smartphone on a Space Explorer. This is a very nice free application. It's named Satellite Chaser. Is using your position and time to show you around the Earth which are the satellites that are flying on your head. And you can select one on the sky, like the video you can see here. You can get the trajectory on the sky, even a number of data on this satellite. This is very nice application. This is another one linked to navigation satellites. This is a picture on augmented reality I taken outside the Italian Space Agency. You can see GPS and Galileo satellites. This is a European Space Agency application in the field of satellite navigation. Is very sophisticated and it can allow you even to understand what is behind a position that is a very complex computation. There is another application named GPS test. It can show you how many satellites are in view, are used by your smartphone to compute your position. You can see in this example is the snapshot. The PDOP is the dilution precision. In this case, we were 2 meters of precision on position and 20 satellites on view. You can even better accurate. And then you can see the list of the flags are the constellation that are used for the computation. Then are Russian, European, American, and Chinese satellite that are all together used to get the position. This is another very nice application to observe the moon. If you take a look to the moon with a telescope, you can know in advance the characteristics, the phases, and details. And this is another very interesting free application named Celestia. You can travel on solar system. I can show you a small video. This is our planet. You decide a target, Jupiter, for example, and you fly directly on the Jupiter. And you can fly around, look to the satellites around Jupiter, so on. It's very sophisticated, enjoyable application. Another one is the way to observe the sky during the night. Stellarium is another free web-based application. You can have browser-based application, even a smartphone application. Then I was trying to imagine the sky this night, 25th of March in Kabul, in Stirling, Scotland, in Turin, to compare the position of the stars. This is another application, visibility of International Space Station, allow you to know in advance when ISS is flying over your heads, and maybe you can see during the transit. This is another one that is showing in real time the view from the windows of the International Space Station. This is live coming directly from the International Space Station. It's very nice. This is another one for who is looking for a very sophisticated picture, like the transit of ISS on the sun dish or on the moon dish. You can have the forecast of such paths that are very critical. Takes few seconds to transit, and of course very depending on your position on Earth. And this app allow you to make this computation. This is another application to know in advance the passes. And the last one, if you like playing with a 3D printer, that is something that I'm just starting to do recently, you can go to this NASA website, Track NASA, for Mars, for Venus, for Mars, for Moon. You can select a region and you can extract the file to be used for the 3D printer. You can build your own model of the specific area of Mars or on the Moon. And there are even a lot of 3D resources, like, for example, West Asteroid, models of spacecraft to be seen in 3D or even to print in 3D. And this is a site of ESA, in which you can see there are a lot of resources to be downloaded. And this is the site of ESA Kids for small students, young students. And this, of course, is the end of my presentation. The material has been already provided for the application and for the paper model. And then if you have maybe questions to be raised, I'm very happy to answer to questions, trying to provide you some clever answer if I can. Thank you very much.
I wanted to ask you, what will artificial intelligence role in space missions in the next 20 years?
Very interesting question. I think that the most important role is to increase the processing capacity. Today we are collecting a plethora of data from satellites orbiting Earth, exploring our planets, the moon, and in most of the cases the challenge is not just making the processing, but even to make, if you like, parallel of data and to detect specific characteristics. Then AI will help a lot of on processing of this plethora of data and to maybe detect specific trends, characteristics that maybe are not so trivial to be detected. This is a first, if you like, role that can be developed and that is already, if you like, under development. Another one is the total autonomy of spacecraft, because as soon as we extend our exploration area, we can imagine to have missions in which the distance is not allowing us to real-time control spacecraft. And then the fundamental need is to have autonomy of spacecraft to take decision not only on nominal condition but even on contingency condition. Then, if you like, the artificial intelligence is, if you like, another way to increase the smart spacecraft robot to take autonomous decision in front of real-time contingency. Last one is the example I shown you, is the way of have totally autonomous missions. Then this is really the far future. Then you can imagine to send on space a spacecraft that is not aimed to develop a mission fully defined in advance by you, but you can leave the spacecraft, then becomes a sort of intelligent robot to adapt itself to the different conditions that we'll encounter during the flight. Of course, we are thinking to mission that will pass for decade of years, and then of course even a generation of research on Earth can get data from such a robotic mission that are developing step by step collecting data. This is more or less a panorama we have in mind.
If also Mr. Manson class want to ask some questions, please open the mic.
Hi, can you hear me?
Yes.
I wanted
Morning.
to ask, when do you think we will be able to study other galaxies out of the Milky Way?
Very nice question. Indeed, at the very beginning of the astronomy story, the astronomers using the first telescope were not able to distinguish on the sky stars that are part of our galaxy and strange bodies that are appearing a little bit vanishing on the telescope view that are the other galaxy. And this has been, if you like, a big question mark for a number of years until somebody discovered the Cepheid variable stars. That is, if you like, a cadeau that is coming from universe for astronomers, because it's a very simple way to compute the distance of the stars, just measuring the variable period. Why? Because these Cepheid stars are special stars that are normally present in any galaxy that has these characteristics. Depending on the size of the star, their period of variability of the light changes. Then, small is the star, more frequent is the variable light. Big is the star, less, more time takes the variable. And this, of course, is a way to compare the visible light of the stars and to, from the time of the frequency, compute the distance. And this was the way to measure for the first time the distance of the far galaxy and to confirm that the other galaxy are something that are external to our galaxy. This today for us is a given, is an information that everybody knows, but in the past this information was not obvious, and only through this computation has been demonstrated. The second way is the famous redshift, that is a way to measure this phenomena that has been introduced by observing the light of a body that is moving with respect of the observer. The redshift, in fact, is named red because if the body is traveling, increasing the distance from the Earth, the spectrum of the light is moving on the red direction. If the body is coming in your direction, is moving on the blue. Then, by measuring this redshift, you can understand how much a star, a galaxy, is far from us, even because cosmology introduced the concept of continuous expansion of the universe. Then, as you can see, even observation from Earth through celestial physics and measurement with sophisticated instrument like spectrograph on telescope can give us a lot of knowledge of the composition of the universe. Any
Hello.
other question?
Yes. In your opinion, how will life in space change over the next 20 years?
First of all, I think will be fundamental the commercial dimension of the space. Let's say after a period of pioneeristic approach in which space was a challenging during the, for example, during the Cold War was a matter of, if you like, making, if you like, supremacy in technology between USA and the Soviet Union. Now we are a very mature phase in which space is not only, if you like, a military field, is really something that are, if you like, seen a lot of commercial actors engaged. There is a business. Even in exploring the moon, there are already private companies that has been engaged by NASA for the Artemis program. This is something that is completely new. In the past, was really forbidden to have a private company developing a lander, a spaceship. Today, NASA is widely using contribution of strategic asset in terms of contribution. Then I see in the future really a combination of, if you like, an institutional umbrella, even at international level, to dictate rules for ruling the way to explore the space. An example is the use of artificial intelligence, to use of nuclear reactors outside the Earth without polluting extraterrestrial bodies, the concept of property of our bodies. Nobody can say the moon is ours because we reached first. An asteroid cannot become ownership of somebody. There are a lot of international rules to be defined, and this will open a lot of contribution of private companies. This is more or less what we will see in the next 20 years.
What technologies will be the most important for future missions to the moon? Sorry. No. The technologies will be most important for future missions to the moon and later to Mars?
This question. Because on the moon we were already there with Apollo mission, but was completely different objective. It was just to reach the moon and to demonstrate a technology that allowed to reach our satellite. Now the concept is sustainability. Even the risk to have, if you like, astronauts exposed to risk, even to live the life, are not acceptable today. Then exploration with astronomers and with astronauts is completely different. When you put astronauts on starships, you go on the moon, you need, if you like, not only sustainability from an economic point of view, but you cannot risk the life of the astronauts. Then you need a lot of extra budget to introduce a number of assets that will create the condition for sustainable presence. Just an example, when you send a robotic mission, you spend €1. When you send an astronaut, you spend €1,000. This is the comparison in terms of engagement of budget. Then missions with astronauts are very complex, expensive, and of course with a lot of implication to protect life. Another big problem would be the duration of the life of the missions. Today, the experience gained on the International Space Station demonstrated that astronauts can work on space for more than 1 year. Medical experts has studied a lot of the effect of this presence on space, and of course there are a lot of drawbacks in having a human body not fully covered by atmosphere that is protecting the radiation, the fact that there is microgravity is generating a lot of problem to human body. Then all these, if you like, medical aspects has to be studied, and the safe of the astronauts is at the first position. Then assume to have 6 months of travel to go on Mars is something that is today quite impossible. Then another way is the development of different ships, spaceships that can travel at a speed that is 10 times more than the actual chemical engines. Then another technology that is under development is the way to reduce the time to travel to solar system to allow astronauts to go even not only to the moon in few days, but even in 1 single month to Mars instead of 6 months. These are more or less the topics under discussion.
Oh, sorry.
Any other question?
We wanted to ask if from Scotland our colleagues have greetings or questions. They said they couldn't use the camera, but I don't know if they can join us just to say hello. I don't know. Ah, yes, okay.
Hi.
Yeah. Hello.
Okay, great. I was going to ask, what kind of breakthroughs or like inventions that we've got from space research benefit us in like everyday life that could be used on like phone purposes?
Not catching the question. Can you repeat, please? Because the audio is quite bad.
You can also
what-
write the question in the chat if you want.
Relatively easy. My question was, what kind of breakthroughs or inventions that we've got from space research can benefit us in everyday life that have multiple purposes?
Nice question. Yeah, this is named the technology transfer. I mean, each time we develop technology for going on space with the astronauts, but even with the robotic mission, we develop technology that are, if you like, fully dedicated to space, that are not already existing on our daily life. And this, of course, we discover later that there is a return in using such technology as soon as it becomes mature and low cost in our daily life. And this is named the technology transfer. And the technology transfer works even in the opposite direction. Then, as soon as space exploration began a commercial domain field, a lot of commercial off-the-shelf technology are used for space exploration. Just to make an example, in our presentation, we have seen the first helicopter, the drone on Mars. This small, fantastic experiment has been developed totally with commercial off-the-shelf technology. To save money and time, somebody in NASA decided to test a possible drone on Mars without spending a fortune, and they used the commercial camera, commercial electrical engines, components, and they demonstrated even such technology is usable on space exploration. Then, if you like, is double direction exercise to develop, if you like, technology from space to Earth and from Earth to space. Of course, on space, there are a lot of different, if you like, requirements in developing technology. As I said before, safety is the first as a requirement. Then, for example, the protection of the astronauts from radiation is something that is, of course, peculiar to space exploration. But just to make an example, a lot of medical examination today on technology are derived from the space sector. Then, if you like, making medical analysis by remote during a space mission is fundamental to develop telemedicine application. That tomorrow we can have, if you like, telemedicine on Earth, even for remote site, having medical experts not in presence, but using technology that normally today are used on space sector, for example.
I was just wondering, do you think there's life out there and will it be possible to find it?
You didn't
Sorry, we
catch
didn't
the
hear
answer?
you well.
Oh,
Yeah.
okay. Do you think there's life out there and do you think it'll be possible to find it?
I didn't understand the question.
Okay. Do you think there, well, I was wondering, do you think there's life out there and will it be possible to find it?
I had a life outside, life outside the Earth. It's what I understood, right? If there is something outside there. Is it correct, Mr. Manson? Mrs. Manson, did I hear
Yeah.
well? Okay.
Yeah.
Thank you.
The most difficult question.
Yeah, exactly.
Indeed, the search of the life outside our planet is one of the, if you like, big objective that is today made with different modality. In the past, the only way was making observation in situ, collecting samples. Today, with the research of exoplanet that is developed with a lot of space telescope, we can increase our capacity to detect, if you like, with very sophisticated telescope, with high accuracy observation, planets that are orbiting around other stars. That has, if you like, not only the right distance from the relative star to allow a comfortable temperature, but even with the measurement of spectrography to understand if the planet has an atmosphere and the composition of this atmosphere that is compatible with development of life. That is a way to, if you like, discover trace of life on other world. This, of course, nothing to do with the problem to be in contact with the intelligent life on other planets, because this, of course, is completely different. Recently, the chemical analysis of the samples of the asteroids made by the mission, Japanese mission I was referring before, demonstrated that from the samples, the researchers has discovered the basic chemical composition of, if you like, precondition chemical composition to develop the life. Then there are scientists that are, if you like, believing that the life has been introduced on our planets through comets, asteroids, rather to be developed on our planet itself. Now, this is a very interesting theory that is saying that maybe we are alien on our planet in this extreme case. By the way, the life outside our planet, unfortunately, on our solar system can be limited to very few cases. We know Mars is one candidate, maybe in the past. Titan, that is the biggest satellite of Saturn. Or maybe there are other satellites that has water, ocean on surface that can protect life from radiation and can keep the temperature at the right range. But this, of course, today are just a theory, are, if you like, giving objective to future missions.
I think we have, okay, another question.
I wanted to ask you, do you know some inventions that first were created for space, but then now we use them here in everyday life? Yes.
Yeah. In the field of this technology transfer, I mean, a lot of time we have seen on the web such a list, like for example, the tomography axial computation, the TAC is the analysis made on a medical field. Today we can use the TAC TAC, tomography axial computation, is a way to observe our body as alternative to X-ray. This has been developed by NASA for a very strange reason, to check the integrity of the rocket. Then after the manufacturing of the very big rocket to go on the moon, one of the problems was to check the integrity of this body of the rocket, since it was subject of very high temperature pressure during the launch. And to check such integrity, they invented such technology that after has been developed. Today we cannot, if you like, imagine to have a medicine without the TAC, TAC. Another, of course, example are material. When the space adventure was at the very beginning, the Kennedy, president of USA, was asking to NASA to have the astronauts on the moon. The engineers were if you like, asking to ourselves what to do, and they discovered the technology was not at the right level to go on the moon. And this is an example of how much space is a way to challenge the researcher, the scientific developer, to do something that today does not exist. They developed specific metallic components, very light, very robust, that today are used, for example, on our motorbikes, on airplanes. Then a lot of technology today we have in everyday life has been developed with a lot of effort in terms of budget and capacity of engineers for a very specific challenging mission on space, but then the return of the benefits has been immediately after reused on our civil life. That is another example. Special material like carbon fiber, for example, has been developed on space. The digital camera. The digital camera today, everyone on a smartphone with a digital camera that at the time of Apollo mission was not at all invented. At the time of Apollo mission was analogic camera. available. Today, the Artemis mission is, of course, based on digital camera with high definition capacity, and even the telecommunication of high definition video is part of the mission. Then telecommunication within robotic mission, astronauts mission, and Earth are another field in which technology has developed a lot. Today, if mobile phones network are present, it's because engineers has worked a lot on telecommunication with sophisticated machine, in which you have to use limited bandwidth, let's say a small transfer of a bit, but with a lot of technology. Then the concept of, for example, of zip file, to encrypt an information. This is another way to reuse the technology developed in space. In the future, spacecraft were sending image data to Earth. To limit the use of the data to be transferred, they use the way to zip, to encrypt the data, and to limit the bandwidth. Today, we use this capacity every day when we maybe chat on social.
Okay, so a huge thank you, Dr. Musmeci. It was an amazing presentation, and we we were like you in space during your exploration in the past, in the present, and in the future. Thanks a lot also to the young colleague from Treccani and for the colleagues also from Scotland, and all our students in the staff. You cannot see the staff. They are behind us, and they let us every time be online. And thanks to Mr. Campisi and Mrs. Plotteger, my dear colleagues. So enjoy your day, and thanks for joining us for this incredible event. Thank you so much.
Thank you very much.
Thank you very
Thank
much,
you.
guys.
Thank you.
Bye. Thank you very
Bye.
much.